Today we're going to talk about the projective plane, and to motivate this discussion, let's talk about what we know about the basic geometries of points on lines. So what we know is that if you have 2 points, I can always draw a line through them. And similarly, we know that if you have 2 lines, then they almost always intersect at one point. But we know that this intersection point does not always exist. In particular, if I have 2 parallel lines, then those 2 parallel lines might not or do not intersect in normal geometric plane. And with the projective plane, we try to fix that issue. And in particular, in the geometric plane, the goal that we want to achieve is that we want to satisfy 2 properties. One of them is that from every 2 points, we can only draw 1 line. So from every 2 points, we can have 1 line that goes through them. And the second property is that for every 2 lines, there is only 1 intersection. For every 2 lines, then we get 1 intersection. In the normal geometry, the property 1 holds. But property number 2 does not hold for parallel lines. And we'll try to fix that issue. Okay, so the starting point is to observe that if I have 2 normal lines that are not parallel and 2 normal points, then I don't have a problem. So obviously, the problem that I need to fix is the issue of a bunch of parallel lines that they do not intersect in the Euclidean sense. To fix that issue, well, we could just try to make up a point at infinity. So let's say this is a point at infinity, and we can assume that all these parallel lines intersect at this point at infinity. Like they go all the way to the infinity, and then they pass through this point at infinity. Obviously, this point at infinity does not exist in the geometric plane, and this is just a representation of it that around this picture. But then you might ask, what about the other side of these lines? Well, we cannot add another point at infinity, because if we do that, then those lines intersect twice. They intersect at this point at infinity, and they also intersect at that point at infinity. But what we can do here, we could assume that those 2 points at infinity are the same. So now we could assume that all of these parallel lines intersect at the same point at infinity, whether on their right or whether to the left. So this is the same point at infinity. And with this, it seems like we have fixed all the problems, because now parallel lines intersect, and of course non-parallel lines intersect in the normal way. But what about the first property? And the first property said that from every 2 points, I could draw a unique line. Well, if you have 2 normal points, then that still holds. You could draw a normal line. But what if one of the points is the point at infinity? Well, in that case, it's actually not so hard, right? For example, if I pick this point, so this is point P, and let's say this is the point at an infinity Q. What is the line that passes through points P and Q? Well, if you think about it, well, it's a line that is parallel to these set of black lines. It passes through point P, and of course, it goes through the point at infinity Q. Okay, so it looks like we're done. We have fixed everything. But there is one problem remaining, and that is, what if I pick 2 points at infinity? So, for example, I could draw these other lines that are also parallel, and they have their own point at infinity along that direction. And that point at infinity is different from that point at infinity, because these 2 lines intersect. So let's say this orange line and a black line intersect in an ordinary way. So therefore, their point at infinity should be different, because they cannot intersect twice. But what is the line that goes through those 2 points at infinity? To fix that, we actually need to add the concept of line at infinity. So the line at infinity is a line that goes through all the infinity points. Doesn't go through any normal point. It only goes through infinity points. And if I add this line at infinity, then I'm actually done. I'm good, because this was the last missing case. This covers the line that passes through two infinity points. But what about the intersection of the line at infinity and the normal line? Well, that is also not a problem, fortunately, because if you take, for example, any of these black lines go through this point Q, which is the point at infinity, and it's also the intersection of the line at infinity and these normal lines. So, and if you go through all the properties, you'll see that with these additions, I have actually fixed the problem. I have made Euclidean geometry consistent in the sense that every two lines intersect at one point, and from every 2 points I could draw one unique line.